What about now? Can you hear me online? Can you hear me now? Yep, okay, cool, great. Great, so today's lecture will be relaxed, I think. It's not very hard, but it's very helpful, very useful, especially for iteration 2. Because in iteration 2, we are going to have persistence layer. Okay, but it's very simple, very straightforward. So let's have a look. What is persistent layer? So this is one of the topics that we are going to talk about today, and how can we have that? Okay, so it's actually about data. We have data everywhere, like variables in our code is one kind of data, right? And we also have different, like we put in the URL yesterday, put in URL like Apple name equals Yuchao or Jake. So this is also another type of data. Yeah, and data, sometimes we need to record it. Sometimes we might not need to, okay? Here's a really interesting topic, like what's the difference between data and information? Do you have any idea, like any guys, like what's the difference between data and information? Yeah? Okay, so in my understanding, like data can be any thing, any data, but information is something that we get from that data, like what we learn from that. It's like what is the information we get. Okay. And data science or big data and related topic has been very, very popular these days. Like in machine learning, in ChatGPT, we use a lot of training data, right? And we also learn how data can predict for like the stock or anything. So it's very popular topic these days. And here we also have a lot of courses, different courses on data. But here for this course, like software engineering fundamentals, we are only going to touch a little bit about that, especially for this data layer. So because it's a fundamental course, right? So we learn a little bit about that, a little bit about this in software engineering. And then you can go deeper by taking other courses and doing more practices. Okay, so here's where data is in applications. So as we just mentioned that data is part of every software application, such as the variables. But when we talk about data in softwares, we mainly referring to the data layer. Okay, so there are different ways of naming this data layer. So sometimes we call it persistence layer, sometimes we call it data layer, but persistence is a kind of more broader term. And for this architecture, this kind of software architecture or structure, we also have many different ways of presenting it. Like really based on how you design your software, like how your users' requirements are and how your software is working for. So for example, what we have here is we have interface layer, like what we can see like as a client or as a user, and we also have some business logic layer, what other stakeholders can do with your software. Okay, and service layer is more about like login, logout, registration, a little bit more fundamental than business logic layer. And now we also have data layer. Okay, and there are also other ways of this kind of software architecture. For example, we have presentation layer. Sometimes when you heard the word like presentation layer, it's just what you can see. And sometimes we also have you may also heard of the word like application layer, where we make the features working, the application layer, and we also have this data layer. Okay, so we are not going very deep here, just a quick overview, like a high level of it. Okay, so data layer, always we mean like database here. Okay, so database is a word that is used to describe a store of data, And databases are typically what a data layer consists of. And there are a couple of ways that we can store data. The first one, the most easy one, like most straightforward one, is in memory. So we store data in memory. This means that if we restart the server or we restart the machine, the data is lost. Because it's only stored in the memory, right? But sometimes it can be also very useful. For example, because the data stored in the memory is very quick to get from the memory instead of from like a complex database, so it's very quick. So sometimes when in some games, when we have a leaderboard that we need to refresh like every second or microsecond, we need to get data very quickly. So in these cases, the in-memory way of storing data can be very helpful. And also, there are some other examples. But there are also other ways of storing data. For example, here we have in-file. It's called in-file file system direct storage. So this can also be useful in some cases. For example, if in a group of people, like you work on same file, same source of data, and you can share this file within your group, right? And so this is the upside of it, but there's also the downside of in-file. So because it takes a lot of storage, it's really hard for scaling. So traditionally we have in-file storage like working well, but as the scale become growing and growing, we kind of introduce another way of storing files like on the cloud. So many cloud-based services provide like in-file data storage, such as AWS or IBM. They all provide this kind of service. Like they allow you to store your files on their cloud, and you pay only a little bit money for it. And there's also a more powerful way of database or data layer, which is in a database. So database is actually like you can relational database, the one that you can learn from 3311 if you are interested, is kind of storing data in tables, so that you can have some relationships between the data, you can have some constraints on the data. So it's very powerful, like if you have a database, but it's more complex. Right. So in this course, we will mainly talking about in-file data storage. Okay, and if you want to learn more about relational SQL, 3311 is a good course. Yeah. So yesterday's lecture, we talked about HTTP server. And as you can see that the information we put there when we restart the server, everything is lost. We are going to see that again today. But sometimes we want the data to last longer, so we may want to store it in the files. Okay. So this is where we introduce the term called persistence. So it is actually quite broad concept. It's more than just storing data. It's kind of storing any status in your server or in your application. But here, we only want to focus on storing of data. Okay, so the definition of persistence here is that when program state outlives the process that created it. Okay, so this is achieved by storing the state as data in computed data storage. So when you restart server, we still want the data to be there. We do not want to. So persistence can be interpreted very broadly, though in this course we will focus on data, storing data to disk. Okay, so how can we modify the project server that we worked on yesterday and to have like persistently store our data? So how can we do that? Any guess? Like how can we store data in file? Okay, so for the project, as I mentioned that you are going to have a persistence layer. And will only use very simple like info database, and we are going to show it very quickly. And this needs to consist is a loading and storing the state of your program in a JSON string that is stored on file. So remembering that when we talk about standard, like when we talk about JSON, XML, and YAML, we talk about how we can save, like how we can write a file, write your JSON data to a file, and how we can read the file, read JSON file, and decode it into a JavaScript object. So this is actually how we do that. It's pretty straightforward, right? So let's have a look at some examples. So it is a good opportunity for us to recap actually what we learned before and make practice on it, right? So this is the slides that we used before when we talk about JSON. And here are the code that we demonstrated before, like how we read file from a JSON file and JSON .parse, like to have a JavaScript data. So this is read. We are going to use that today. And also, oops, where's the right? Oh, here. So we also have fs. Remember that we talked about this before, like fs.write file sync, and so that we can write all of our data to a JSON file. Okay, so let's try that out and see how it works. Okay, so when yesterday we talked about how we communicate with HTTP server, we talked about how we write scripts to test our project server, right? And we skipped yesterday about how we use a kind of interface or a tool to help us test. It's not in your iteration tool, but sometimes it can be quite straightforward for you to test. So the tool is here called ARC. The way that you can get it is simply through like you open a Google Chrome and you search here as Chrome ARC. Okay, and the first one shown here is called Advanced REST Client. Remembering that we are writing a RESTful API. Okay, so this one is called Advanced REST Client. And because I have already installed it on my Chrome, but you might need to install it first, and then you can launch this app. Okay, and you can also see that here's a very quick, can you see it clearly? Is it better? Okay, cool. So here's an overview that you can read from their website. So it's useful for web developers. Like it helps you to create and test your HTTP requests. Okay, it's an API testing tool. Let me show you how to use it. So this is how it looks. Okay, we talk about how we can get content by putting variables in the URL. So it's here. Let me show you. Okay, so we get from this URL. So let's run this. I need to run my server first. So this is actually the code from yesterday. We are going to, based on yesterday's code, and add some write and read to JSON today. Okay, so it's listening on port 3001. Okay. So hi, I'm Defan, thanks for sending apples, because I didn't put the name value to it here, right? But what we can also do is remembering that, so this is the code from yesterday, right? So we also have a code about post. So the way that we get value for get is we put the value in the URL, right? We get from the query name. But for post, we get from the body name. Remember that? It's a very useful recover sometimes, I think. Like after one day, when you finish a lecture and you revisit it, it kind of reinforces your memory and your understanding of it. Okay, so here is it. So what if we have a post here, okay, from orange, and we need to put a value here in the body. Can you see it? I can't zoom in this app, like this interface is different from browser. I can't zoom in. I hope you can see it clearly. Otherwise, I can just explain. So we click on the body here. So here's a tab called body, okay, and we put the name value as 35 here, and we send. And it will print this message like, hi 35, thanks for sending the orange. Okay, I think you might not be able to see it clearly, but let me try again. Oh no, I still can't zoom in. Okay, but what is showing here is a message. Highlight it? Now? Is it better? Sorry about that. It's different from a browser. We cannot zoom in. It's not very, so we can say that the UI or UX design is not very helpful, but it's a powerful tool. Like you can test your server. Yeah, question. Sorry? Yeah, you can see it, I know. So I will read it to you. It's name here. It's name, like the value that we want to put. Oops. It's here, like we want to put in the body name. So we have the variable name as name, and the value we give it is 35. So here's 35. And the message displaying here is what we console logged in this app post. So it's a message, and the name is replaced by the value 35. I just randomly give it anything. And thanks for sending the oranges. It's displaying here. Okay. Yeah, so this is a quick way for us to test your server. Okay, so let's then, after this recap, like looking at the code from yesterday, now we can add some code to it so that we can save our data and read our data now. Okay, so the way we do it, so first of all, to be able to read and write from a JSON file, we need to have this import fs from fs library. Right, when we talk about JSON, like to be able to use the write file sync and also read file, we need to have this library. So this is the first step, and this is exactly the same as the code we had yesterday. Okay, so we define the port and we are using the Express server. So this is what it means here, and this is also the same, exactly the same as what we used yesterday. Okay, so now what we are adding here is that we want to have a data, right? So we want to read and write data. So I define like a data here as any type because I'm not using any specific tag here. So I put any and I initiate it with a value as null. Okay, and I also had a file called export JSON, and I put a JSON string in there, and the value is I put 45 as value to A, and you can see A is here. As just we will use that. We will demonstrate how we use that. I just quickly explain to you the code, and then we read from this file. Okay, so we read from this export JSON file. Okay, and then so this is exactly the same as what we learned when we talk about JSON. So we read from this JSON file and we JSON pass that string, that JSON data. Okay, okay. So let's skip this for now. It's about write. We'll talk a little bit more about that later. So now we have we read this file, okay, and we put the data here as like yesterday. What we had was hi name, thanks for sending the apple in this .json command. And now what we put here is just this A values from data. It's passing through from here and getting the data from that JSON file. Okay, so let's demonstrate how it works. Okay, so not this one. So let's run this. I need to run the server first to make sure that it can work. Okay, so I was running the code from yesterday. Now I need to have a new one, like running what we have today. 5.2. Okay, so it's now listening on port 3000 as what we had here. So we are using the port 3000. Okay, so let's have a look here first. 3000 Apple. Oh, I need to have the slash here. 3000. Okay, so this is what is shown here. This is what we get from this JSON file. So this is what we read from that JSON file. Okay, so we are not passing through the value through the URL. We get the value from a file. It's the .json file. Any questions now? Yeah.
So what comes out of the .json file is just a string, so you can't give function or anything.
No. So JSON is not a programming language.
But you can't store a function in it or out.
Whatever you put in the JSON file is a text. So you can put a function here, but it will read it as a text. Okay. So this is, we read data from that JSON file. So what we can also do is we write the data to that JSON file and update that data. Okay, so the way we do it is through this like write file sync, so that we can write data to this file. Okay, so this is the data we have here, and we write to this file. It's exactly the same as what we have seen before. So let's have a try. So I will use this one. Am I using 3000? Yes, right. So we put here. Okay, so the way we get value from, like when we, as a client, we can communicate with the server by using post to post the information to that server, to push value to that server. And the way we use that is through body. And here we are using input X. So the way we use it as, again, you can't see it, but I will read that to you. It's input 45. It's the same as what we see name 25, right? And then when we send this data, and let's have a look at this JSON file. It's 45, right? Yeah, we used to have 25. Now it's updated as 45. So that we can save the data, we can get the data from the client and save that data in a file. So that last time when we run this server again, the data will not be lost, it's still there. So that we can read directly from the file, the JSON file, and use that. So this is how we get the persistency. Questions? Oh, good. I also found that, okay, cool. Sorry? Maximum file size for a JSON file? I don't think so. I don't know, I'm not sure. Yeah, but normally should be enough. But in real scenario, we might have a lot of JSON files. So that's when it causes trouble to the storage. So in that case, we might use a cloud-based server. Just all files. Yeah. No worries. Okay. Yeah, so let's play with it a little bit. Okay. So you can always add more here. So now we only have A, right? You can put more like B and C and D. Then the only difference is here. We will have more values here. Right? As you mentioned, like how large like JSON file can be. Okay, any questions from online? All right, I always found that due to the middle of the term, like everyone's becoming more quiet than the beginning of the term. yeah, hope the labs and the projects treat you well. Okay, so cool. Is it very straightforward? I think so. But for this one, it's a quite useful tool, but you are not required to use it for like projects or anything, but you can use it to test. Okay, so in previous term we had exams and we use that for exams, but you can always play with it. Okay, so another thing that when you use this tool is you might need to make sure the header name and the header value is properly. We are not going very deep to it, so you just use content tag for the header name and application/JSON so that it will work. Okay, cool. And when you are using post or put or delete, remembering to put your data in the body instead of in the headers. Okay, so this is just how we get value through different CRUD method, like remembering that we have get, delete, put, and post. So this is just different ways of us communicating with the server. All right. Cool. Because this code is not in the slide, so you can feel free to have a look at video recording or take a photo of it. So it might be helpful for your iteration too. So we kind of give you this code that you can use it. Okay, any questions? Okay. Sorry? Where I call the function to save the data. Okay, so we save data through the right thing. Oh, this is not the correct one. Here is it. So we use fs.writeFileSync to write data to the JSON file. When I call the function save, yeah, good question. I call it here. So I define a function called save, and I call this function when I post to the server. Right? I didn't have any like parameters or variables or anything here. I didn't make it very complex, but you can always put in more information to the save function. So I define the save function here because I'm writing this global variable data. Right? So I do not need to put this variable here in the save or anything. I got this A from body input X, and I put this input X through here, the body here. Okay, cool. All right, let's go back to the slide. Okay, so we just had a look at like how we load and save data. Yeah, so here's a summary. Like on load on the server start, open the JSON file as what we did. Like I put the A as 45 like in the JSON file, and when the server start, it opens the JSON file and set a global variable to be passed JSON object. And when we save, like when we have a data variable or anything that we want to save, either based on timer, I will not cover that now, but or at any time, like we can JSON stringify your global variable and store it in the file. So this is the process, like how we load and save from JSON file. But sometimes, like here, we are using JSON file, but in reality, sometimes we also use XML. So it's another standard data type like we use to communicate with server. Okay, but here we are using JSON. But you can also use XML or YAML, that's all fine. So based on like what your software is aim to achieve, like your design goals. Okay, great. So feedback for this very quick lecture. I hope that is helpful for you, like get started with the data layer, and also help for your iteration too. And yeah, so we are not touching a lot on the database in this course. Okay, so then we are going to move on to another topic. Shall we have a quick break? Or we start? Yes? Okay. So 10 minutes break, and we are going to start another topic. Okay. What about now? Can you hear me? Oh, I'm so sorry. I just quickly explain what I just mentioned for those online, that we talk about why maintain is important, because like maintain is why maintainability is important, because we are always changing our code, like for various reasons, like when we want to improve the performance, we want to fix bugs, resolve customer issues, we're always changing our code. So we need to make sure that it is easy to maintain. So this is why we have the code design for maintainability. All right. Yeah, so by definition, software maintain. Why are those online still seeing a white page? But it should be fine. Okay, so software maintenance is the process of changing, modifying, and updating software to keep up with the customer needs. And in reality, the maintenance is also costing a lot of money in the software companies. Okay, so we need to make sure that it's easy to maintain. Okay, let's go back to the slide. Oh, no. Convert. Okay. Yep. So today we will be discussing what maintainable software is. Okay, we already talked about this, like why we care about maintainability. Software in the real world changes over time, and less easily maintainable software is the harder it is to adapt to these changes. It also saves money for software companies. And well-designed software is maintainable. It's very critical topic. Yep, different people working on it, requirements change over time. So this is also very important, like why we have like requirements changing over time, because of customer needs change over time. Right, so our like with new things evolving every day in the technology world, like our customer needs also changing over time. So this is also another reason why our code changes all the time. And we also need to increase performance and fixing bugs. And our code is always growing, right? So you can never have a perfect software project. It's a perfect, so we are always working on it, never stop. Yeah, a lot of more reasons. And a hot topic is that like whether maintainable is more important and if performance is more important, like which one is more important? So this is kind of a very popular topic that we discuss a lot. And we will say that if your software project is not maintainable, it will eventually influence its performance. Because when you are adding new features, you are trying to increase its performance, but it's not maintainable, it will influence your performance eventually. So if the code is easy to maintain, it will be easy to speed up for your team and for your code performance as well. But how? So we talk a lot about like why we care about like why maintainability is important, but how? Okay, so how can we make our software more maintainable? So we are going to have so there are a couple of key ways that we can make our software maintainable. So the first one is testing. We talk a lot in this course about testing, like why it is important. And Rob last week, he also emphasized the importance of testing. It's as important as other features. Like, so by verifying the correctness of your code, it becomes easier to make changes to it without worrying about if it is correct. Yeah, so this is, we talk about the CI/CD pipeline. It also helps us with scaling. Like when we make changes to the code, we make sure the code won't make our program, like make our project crash, right? And another part is system design. Like by planning systems to make sense, at a very high level or conceptual level. We will talk a little bit more about that in the future weeks. Okay, it's also important. And today we will be talking about the code design. So how can we thinking about the code at high level as well as low level of details in terms of what makes things resilient to adapt to the inevitable changes in the future. So we are always changing our code. So how can we make sure that our code is resilient to those changes? Okay, so this is code design. So code design, so it's something in the between of the text and writing code. So you first of all, you have some code that works and it doesn't fail the test. It's also when you know what a solution needs to be do, but needs to plan how you do it. So it's kind of, you know how you can get from the computer science building the K17 to here. But there are many different ways that you can get here to the science theater, right? But how you get here, is it an easier way, you can take less steps, have some sunshine or something. So this is just how you achieve your goals. And our tendency is not to write well-designed code. We are often in a rush, as we are working on our projects and our labs. I know everyone does that. We are always in a rush. So this is very common, especially when we also have some pressures on it. But good code design takes a little more time and energy in the short term, but it pays it off in the future. Especially when you finish code and you want to improve your performance of your code, when you want to add something to your code, you want to make your project a little bit more powerful when you're making those changes. If you start with writing maintainable, well-designed code, you will save time in the future, right? But how can we have good code design? It's pretty hard, I have to say, really build on your experience, how many codes you have written. And also, the feedback is also important, your feedback from the tutor and everything. But there are some things that we can think of when you write out code. So it's good that we start by discussing about these questions earlier instead of the end of the term, so that you can keep those questions in mind when you are writing for your labs or your projects. Try to do them. I think most of them will not be achieved suddenly, but as long as you think of them, practice them and talk with people about them, you will get better. So here are the questions. So the first one is there one source of truth for that? So let's go through them one by one. Okay. So this is quite common and it's easier to start with. So this question. So sometimes we may have a piece of code very similar chunk of functions here and there, and we have different name of it, but they are doing very similar things. Okay, so this is quite often so this is how we repeat ourselves. So for example, same value defined in multiple places, and a change in that value will require changes in all locations. Okay, so this is not only in software engineering, right? So this is not only in programming, in code. So it's also in when you read a report, read an essay, read everything. When, for example, we define A as B plus C here and there, in very similar ways. And if you change one of them, you need to change all of them, right? So for example, you have a Google Doc, and at the beginning you define that things as number, N-U-M-B-E-R, and then you use that here and there, and then you decide to change it to just N-U-M, then you need to change all of them, right? So this is quite common not only in programming, and it's very easy to forget to change it at all locations, so that it's not easy to maintain, it's not maintainable. To avoid this, we follow don't repeat yourself, the dry method. So this is quite popular, when you heard the dry, you know it's don't repeat yourself. is talking, like discussing here and there everywhere, is called don't repeat yourself method, like which focuses on reducing repetition in code. Okay, so let's have a look at the example. Can you see from the back the code? No? Okay. What about this one? Oops. Is it better? Okay, cool. Perfect. Have a look and have a second. Think of like, how can we make this code better? How can we design better code? Any thoughts? What about online? Do you have any thoughts like how can we make this code better? Yeah. Huh? Line 4? Oh, you're not sure what this line means? Yes, okay. Let me quickly explain this code first before you look at it, like how to simplify it. So this code is that we import this argument from the processes. So what it does here, like argument lines, is we count the number of the arguments from the command line after npm run. So for example, we have npm run ts node and a file name. So after npm run, so we count ts node and the file name as the number of the length of the argument. So sometimes we may pass on some more in the command. So for example here, let me run this code first. Yeah, it's here. So what I put in here is npm run ts node, this file name, and we have an extra input here, which is 2. Okay, so this code, what this code does is that he taking this argv2, which is here. It's a little bit confusing. Oops, I'll put 3 here so that it's more clear. Okay, so the argv is the value here after. So this is the argv0, argv1, and this is the argv2. All right. So the argv length is the length from here to here. Is that clear? Can you see from the back there? Yeah, cool. Okay, so is it clear here? Like, if it's not equal to 3, so let's see what happens. So what if I stop here? I only have ts node and this file, this. So nothing happened because I acted with an error. Like, it doesn't work, just exit directly. So otherwise, if the argv is 3 here, so what it does, if it's 2, it does this part, and if we got 3, we do this. Otherwise, we exit. So this is what you have seen here. So if I put 3 here, then this number, the value of it is 3. If I put 2 here, the number's value, so num, so this value is 2, right? And I just an iteration, like from 10 to 20, and we multiply with 2 or 3, depending on the number value. Is that clear? Questions? Sorry. Yes, I will repeat for those online and for ID back. So what he said is great. What he said is just we have very similar chunk of code here, right? Here and here, right? So what if we merge them somehow, define a new function, right, and call it put them in one block? Yep, cool. So do you mean that I put like number equals to 2 or number equals to 3? You mean have one for loop and put them together in that for loop? Yes. Uh-huh. Mm-hmm. Yes. Okay. Let me repeat for the others. So what we just mentioned is that these two chunks of code, they are very similar, right? So what if we make them only we only call them once? Yeah. I'm not sure whether I understand you properly. Yeah. Uh-huh. Yes. Okay. So replace this +2 with num, and replace this 3 with num. Is that what you mean? And put them together, right? So you do not need to add if and else if. Is that what you mean? Oh, wrong place. Yeah. Can you just come and so that when you talk, people online can also hear you?
So instead of putting ×3, we can put dollar curly brackets and none. So like if it's like 2 or 3, it goes here. So if that says 2, then over here it will show 2 as well. Yeah, that's. So if let's just say like, so like what he reiterated was that we combine these two together. So if num is 2 or num is 3, so if let's just say we put 2, it will still go here, and then I times 2, and then it will just keep console.log. It will just keep saying I times 2 equals to all of it. And if it's 3, it's the same thing. It will just go to num will be 3, and then there'll be like I times 3 equals to all of it there. And yeah.
Great, thank you.
And we combine them together.
Do you know how to combine it? Do you want to have a try? Thank you.
Oh yeah, that's
great.
That's all.
Thank you so much. Yeah. Anything you want to say?
Oh no, that's all.
Yeah. So we tried it out. Thank you so much. Let's try putting 2 first and see. Wow, that's great. So only if we try 3. Wonderful. So this is great. So this is, we had a great demonstration, like how we can simplify our code and do not repeat ourselves. Okay. Anything more that you think that we can simplify further? Yep. Yeah, so it's a more elegant way of writing the code, right? Yeah, that sounds good. But talking about like repeating ourselves, like the dry principle, yeah, I would just, it's just coming from some previous term, like some students raised like, we have process exit 1 here, right? And we have that again. So what if we define a function called exit and call it here and here, so that we do not repeat it? A function called exit. So the way we do that is so we can have const, right? Exit and no input. And what we do here is just process dot exit 1. And then we can call this exit here, and I copy paste to here, right? Oops. What do you think of it? Like, yeah. All right. So yeah, it kind of helps us with the method of not repeat ourselves. But if you raise other issues, we will discuss later. Okay. So when we talk about other questions. Okay. So this is this example. Are you all good till now? All good? All good? Okay. Cool. Great. So this is the first one. This is the one that we can start with now, like when you are working on labs and projects. Okay. So the second one is it as simple as possible? So the key is here, like we always try to use the simplest tools to solve a problem in the simplest way. So we try to remove any of the lines that we can remove, so that there will be less issues and less things that we need to maintain, right? So how can we do that? So in this course, we used a lot of libraries, right, from NPM, right? So they really helped us a lot. Like we use Express Server from NPM, and we use so they all helped us a lot. So there are some open source code like we can use directly from NPM and maybe also others. So if their code is working well, why do we mind to like write ourselves, which may also have some issues, some problem in not working well, and we need to maintain? So if there's some tools or some things that we can use, that would be great. So when I was teaching like second and third year courses or even postgraduate courses, I often got a question when they do the project, like, can I use open source code? Can I use libraries that other people have already designed? The answer to it is always yes. Why not? So if somebody have already done that for you, why do you want to do that again? You should focus on writing your own important code that there's no other things that you can use directly. Okay. Here's also a principle or method that we usually use. Is called keep it simple, stupid. It's the KISS principle. So you may also see it quite often in the future when you are designing a software. It's called KISS principle. So the idea that a software system works best when things are kept simple, Okay. So here's one example. Write a function to generate a random string with up to 50 characters that consists of lowercase and uppercase characters. How would you approach that? Can you say it louder?
There's a stack overflow post that alters.
Oh, so I will repeat this for those online. So what we said is there's a Stack Overflow post about that. So what did they say? What did they say in that post? Do you remember?
No, but actually,
Yeah, we can always Google. Google is great, especially now we also have ChatGPT, right? Okay, so for now I will just use Google. So what we want is a random string. Okay. I can do this, so that I do not need to hold that. So we are using Node.js in this code. So we search Node.js random string. See what comes up here. Oh, great! So here's make it easy to view again. Oh, great. So here's an npm. So we can see that there's called random string from npm. Yep. They have a link to GitHub. So let's go to the link. Okay, cool, great. So here it shows us how to install it and how to use it. Wow, great. So here's already something that we can use so that we do not need to write our own code, which is fantastic. What about we try that? So what they ask us to do is install this random string. Use npm install random string. Okay. Oh, everything's black. Oh. Do you mind I convert back the color? Oops. Okay. I can't view from my laptop, sorry. So let's install this like npm install random string. Okay, great. So now what they said, we need to include this library and then we can use random string.generate. And there are some more details, examples like how we use it, which is great. Some more parameters, like some more options, like we can indicate the length that we want that random string to be. And we can also have here, alphabetic. If we put alphabetic here, so it will include both lowercase and uppercase letters, which is great. So this is what we are trying to get for this question, right? So we can use that directly. So quickly, I will show you that so that we can move on. All right, so here's, I already have it in my code, so this saves us time. Great. I will just uncomment it. And we need to import that because we are using npm library, right? So we always need to import that. Import random string from random string, then we can console log it and see how it works. Okay, oops. Okay, so what we are going to do is npm run as no, and this file is called 5.4 example 1. It's a TypeScript code. Oops, a lot of errors. Oh, there's a typo. It's TS, not RS, right? Okay, great. So you can all see that I've already had this random string. It works well for me. I do not need to write my own. Done. So this task is solved. So this is what we mean here, like keep it simple as possible. Feel free to use others, libraries, tools, and whatever. So one more example, let me have a look at, we should have time. This example asks us to write a function that prints what the day of the week it is today. Okay, I can do similar things. Search on Google Node.js week of the day. Okay, cool. So here's already a JavaScript we can use directly. We don't need to use any complex NPM here, right? So let's try that out. Copy the code and pass. Oh, again, I already have it. So save our time again. So this is the code from that example. No, this is the different one. I will copy and paste it here. And comment them, put it here, and a console log day. Okay? Run it. 3 means it's Wednesday. It doesn't make a lot of sense here. So it's great that they also give us more example here, like how we can actually print out like console log Sunday or Monday or whatever the day is. So I copy and paste here. Oh, I already have it here. So what I'm going to do is run this code Wednesday. Great, so we found a more easy to use. It's not NPM library at all. It works what we want to be done, right? So this is what this principle is trying to say. Like we keep it as simple as possible. I'm just checking the chat online. The audio sounds like audio auto tune. So can you hear me clearly online? All right. More examples, we are not going to show that. Let's move on to the next principle. So it's called like, is this over-designed or under-designed? Good question. So what is over-designed? What is under-designed? Any guess? What do you think is over-designed or under-designed? Yeah.
Over-design goes beyond what the specifications were, and under-design will be below the specification.
Okay, let me repeat this to those online. Like over-design means goes beyond what the specification requires, and under-design means like less than, like below what is required. Great, I agree with you. So over-designs often means that we add too much to it, like putting in extra complexity that is not necessarily important. And under-design means that like the code may not work as what needed to have. So this is a very straightforward definition of over-design and under-defined here. Okay, so sometimes we might have over-design for performance, like we want it to be fast, we want it to be like better or anything, like have more features, so sometimes we might over-design. But this really goes to what the software aims to have. So it really depends on the purpose of your piece of software. So if for example, if your software does not require to print out something, to actually console log something, and you console log it, it should be fine. But if it's a lot of things, not just console log, it adds to the complexity, and it's not necessary. Right? But there's also another part of over-design. Like we design for the functions, the features, but sometimes we also design for the testing, like design for the correctness, right? But there's a word that there's never over-design for correctness. So if you are designing for testing to make sure that things doesn't crash, there's never over-design for it. Right? But features or performance, sometimes we might be over-designed. And it's actually quite common for software engineer beginners. Like when you are given a topic, like you have given a task, it's often like we want to do good, like we want to be perfect. So we are trying to add this, add that, add everything, like we think might be important. So instead of that, we need to pay more attention to what that software aims to do. So it links to the purpose of the software. So we need to think clearly like what the software aims for. So what's the purpose of it? So that we can make sure that we are not over-designed. So in this course, at the moment, I think we are given quite specific requirements like specs. So it's not easily go over-design. But when you are given a more general open-ended task or projects, it's very easily to go over-design. So this is very common. Like under-design instead is not that often, but over-design is quite often. Okay, but there's not always like a standard way, like one is over-design, one is under-design. Well, under-design is quite clear, but there's not always a border like when you are over-design. So it's really like balancing things, like balancing your design of code, balancing performance, and balancing even budget, right? Okay. And another piece of it, like over-design, like in software engineering, we often like plan. So as we saw earlier, like the software engineering life cycle, the first stage is plan. So we plan ahead, like when we are developing software. So we do the plan at the beginning, and there are often some unforeseen things happening in the future, like when you are really develop that software. So when we plan for it, it's really hard to know like whether we are over-designed or under-designed. Right? So in that case, we look at what is the purpose of that software. Okay. And also sometimes if you over-design means that your code is a little bit harder to change because there are too much complexity. Like we mentioned, like simple is better, right? Yep. Yeah, so at the early stage, very, very early stage, we might be under design, and then we may go a little bit over design. And as our experience growing and we learn more, we do more, like we get more matured, we get good design, like better design. Okay, so next one. Are related modules kept close together, and are related modules kept far? So sometimes we may have different chunks of code in your program. Like we try to put the related one closer to each other. Sometimes we may have different files, like multiple TS file, like TypeScript file, or multiple JavaScript files. So we try to put the more related one together, so that when you are making changes, it's again back to the topic like maintainability. Like it's easy to maintain because related chunks are together. Right, so this is what we meant here, like are related modules kept close together. Okay, so this is also we have seen on the slide that the more software components are connected, the more changes and alterations to one component may break another. Okay, so the sixth question is that, am I speculating about how necessary this is? So this is also very, very common as early stage software engineers. Like when we are given a topic, we always say, well, I might need this, I might need that. It's very, very common. But I made a lot of mistakes earlier about this one. Like we paid too much attention to the details. Like we think, well, this may be helpful. I'm writing a helper function here, and I'm writing another helper function there. I think, well, this will be help with my performance, that will help that. But actually, that is not good. Like I found that many of the functions that I will never use it, and it adds to the complexity. So instead, what is the good way of doing that is top-down. Well, talking about top-down, is a lot of stories about it. Like my supervisor talked a lot to me about the top-down. So what it means really is that when you are given a topic, given a project, given a task to solve, you start with what do you want to achieve. So start with your purpose and then break it down. Like, for example, if I want to achieve A, then I need to have B and C. To get B, I need to have D and E, and then, so this is what top-down means. So the often mistake that we did is we start from the bottom. Like we get a lot of helper functions and try to build up to get like what we really want to achieve. So this is a very common mistake, like we always do that. But instead of, the better way of doing that is we start from what we want to achieve and get like from the top down. So this is often like here's another, like you aren't gonna need it approach. So we talk about dry approach, we talk about kids approach. So here's another one called like you aren't gonna need it. Right? It's also add to our workload, our time needed for the maintain. So this math approach says that a programmer should not add functionalities until it is certain it will eventually be used. Okay, so this helps remove unnecessary code and therefore resulting in having less to maintain. Let me see if we can have an example here. Yeah, so here's the example, like given two latitude and longitude coordinates, meaning that given two positions on the Earth, find out what time I would arrive at my destination if I left now. Assume I travel at the local country's heavy speed. Have a second, think of it, how you are going to approach it. Any idea? Yep.
My first question we have is how we traveling by car or we traveling as a straight flight?
So I just repeat for those online. So what we said is that considering how we travel, whether it's by car or whatever, right? Yep, cool. Any others? Any other thoughts? What about online? All right. Yeah, so I think that is a good point, like how we travel. Assume I travel at a local country's heavy speed. So kind of, but let's have a look at here. So what we are going to do is, what we want is like when. Like, well, this is the purpose, the aim of the task. Like we want to get to know like what time would I arrive at my destination, right? So this is the aim, like what time, we call it what time. To get what time, I'm not writing any code, like using any programming language, just put the structure, the thoughts here. So this is what we aim for, like we want to get what time, right? So to get what time, we need to know how far is it and the speed, right? So we need to know the distance and then we get the speed so that we can get, or we also need to know the time now, right? So that we can get to know what time I can arrive. Does that make sense? Right? So get what time, there are a lot of like libraries or functions that we can use to get a time. So we do not need to write any function of our own. So we just leave it here. And then we need to get a distance. So how can we know the distance? So in this question, we are given two longitude and longitude coordinates, meaning that we can use these coordinates to get a distance, right? So then we want to get the distance, and how we get the distance is through the coordinates. What else we need? The speed is given here. So this is what we mean by top-down. We not start from the details, the bottoms, rather than like, instead of like we start from the top, like what we really aim for. So what we want to get from that piece of code, from that software. And then we break it down, like to find like what we want. Is that clear? All good? So this is what this principle means. Okay, so the next one is, does it follow standard conventions? We talk about linting, right? We talk about ESLint. But there's more than just linting. So conventions, there are a lot of things. For example, we have shown here. So we define something like, we define a function called exit, and we call this here and there. It does simplify our code. We are following the not repeat ourselves principle. However, this is not aligned with the conventions here. So it's not the same like with what the other experienced software engineers are doing. Right, so this is what we mean by convention. So when we have exit 1, it actually means that we are having an error. Right, so when other people maintain our code, when they work on top of our code, they know exactly what exit 1 means here. But if we have another exit here and we have something empty in this exit function here, so it's hard for collaborations because it's not following the conventions. Right, so there are a lot of conventions for different programming language and others. So when you get more experienced, when you write more code, like especially when you work as a team, like you work with others, you learn from how other people writing their code, and you also notice that what problem you encounter when you build on top of other people's code. So you know how you can write better code. So there are also some code design principles. I'm looking at my cheating sheet. I have a lot of links here. So here, make it the color, invert colors. Okay, great. So there are a lot of like conventions or principles. Oh, not this one. Code design principles. Yeah, conventions here. So there are a lot of documents online that you do not need to read all of them and get stressed with all those conventions. You will get used to it as when you are like coding more, do more coding. So here are some examples like C language conventions, C++, and here I think we also have C#, Java, JavaScript, right? So you can have a look at them. Let's have a quick look at this one here. Oops, it's too small. All right. So here's the one. So for example, let's see some examples. So the web space, right? We need to leave some web space here and there to make sure that different chunks of code are not together, too close together. It's hard to read. So this is one example of convention. And they also talk about other things like comments. Yes, comments. I want to mention this one. So comments are so important for maintainability as well, right? So we talk about using variable names that make sense, right? But sometimes, like for example, in a loop, we have I equals 0 and then I minus 10 or something. So when we use I in a loop, it's quite clear that everyone uses that. Right, so this is convention, but if you use others like X or Y or whatever in a loop, so it may be a little bit confusing. It's different from what other people are always doing. It's hard to read. It's hard to maintain. But there are also sometimes we have a lot of variables. Sometimes we need to comment it, like what is variable? What does this variable mean? Right? And also we do not need to put in variables that does not add anything to your code. For example, this one, set I to 0. We all know, like when we read this, like we know it's setting I to 0. So it's useless in some sense. So add meaningful comments. Okay, so I'm not sure whether this is commonly used, but what I always do, like I try to push myself to be top down when I write codes. So before I write a code, like I put some comments in my editor, like what I'm going to write here and what I'm going to write here, some comment, very high level, and then I put my code there, and that comment will live there. It will explain what this chunk of code is doing and what that one is doing. Right? It's easy to maintain, easy for other people to read and build on top of it. Right? So here's another, here it talks about variable declaration. So it can be very helpful. It's also a good practice. It may take some time, right? Take some extra time, like in addition to making your code works, all the features work, it takes some extra time. But it will help in the future. Like when you want to improve that code, add something to it, having these comments are really helpful. Right. Function declarations, we can see the comments here as well. So you can have a look at those. And also how we, some other conventions, like how we use uppercase or lowercase, right? So there are also some conventions for that. Right. Okay, where are we? Yeah, we also talk about this in the slides, like everything from style to library choice. Like we use Express Server in this course because it's popular. Like it's also a good way of following standard convention. Like every people are doing that. It's easy to maintain. Okay, we'll skip that. Okay, so we'll talk about like refactoring. So this is also a popular word or popular term, like when we talk about software maintenance, maintainability as well. So it actually means that we may always go back to our code. So this is very, very common. Like when you have already a working software, and we may always go back to it and make some changes to it. Like we do not change the interface, like the input parameters and what we output. So we do not change those, but we may change what's inside them. So how your code achieve the purpose. So this is very, very common. So this is what we mean by refactoring. So conversations about code design doesn't finish just because the software is finished. Okay, so it can never really finish. So no one writes perfect software the first time. So it's totally fine. But keep in mind those questions that we mentioned in this lecture when you are writing in the future, so that you can practice, pay attention to it, and then you can get better and better. Start to ask yourself those questions. And refactoring is the process of restructuring existing code without changing external behavior. Like what your code doesn't change itself. Like what we get from input will be output. So the interfaces doesn't change. But what changes is what the performance in it. Perhaps also include some security within your code or anything. Questions? Right. So typically this is to fix poor design in existing code to make things more maintainable. Maintainable. We are repeating that word a lot today. Right. So typically it is to fix poor design in existing code to make things more maintainable. So refactoring is refactoring is strongly discouraged. You don't have a strong test suite. So yes, this is very important. So CI/CD pipelines and the test suites, they are very, very important, especially when you are refactoring your code. Right. So make sure that you have, this is also a good practice, like software practice, having good testing suites. So we often make that mistake. Well, the project requires to have CI/CD pipelines, so I finish all the code first, and then I add CI/CD pipelines. So instead, we should have our test suite as early as possible, so that when we are trying to improve our code, we make sure that our code works as what we want it to do. Right. So to have the test suite. So blind refactoring may introduce more bugs than the cost of harder to maintain software. So emphasize the importance of testing again here. So I know like testing and debugging is less interesting than we read some code that have some new features. It's not as exciting as adding new features, but they are so important. They should be an important part of daily life. Like when you fix the bug first and then you write new features later, so that you do not add on the issues to your code. Yeah, cool, great. I was afraid that we can't finish it, but this is great. Let me see. Let's have a look at more examples. Yep, so here I have a lot of links. Code design principles. Yeah, we talk a lot, most of it in the slide, but oops. Oh, yes, great. So there are a little bit more, but we talk a lot, almost all of them. So the first one is like just recap, like what we learned. Like we talk about keep it simple, stupid. So we call it KISS. Remember that? Okay, as simple as possible. And next one is the dry code. Do not repeat yourself. Okay, write higher level functions or whatever so that you do not repeat yourself. Okay, so this is one ugly example of repeating again and again, right? So we can make it a little more simpler. Okay. Yeah, we'll skip that one. So open and closed here, what we are trying to say is that we do not change the outside, the interface of our code, because somebody else may be using our functions or using our code. So if we change the interface, it may influence others who are using our code. So they will get, oh, I can't use that anymore because of what I changed the interface. But you can always change what inside your software. Like you can improve the performance, you can add security to it or whatever. Right. So this is not very related. Yeah. I will repeat this question. So the question is, do we not change the variables or parameters for functions? So it really depends. So it's a very small minor function in a large chunk of code. Feel free to change that. If it's just not an interface, like other people. So for example, we use APIs, right? We also use libraries from others on NPM. So as long as the interface doesn't change, you feel free to change what's inside. You can have more functions, less functions, even remove those functions, it's fine. Yeah. Yeah, and this is also another important one that we mentioned, like you aren't going to need it. We also talk about that in the slide. Do not assume that you will use this or that. Only include the things that you already know that you necessarily need it. So this is also related to what we mentioned about top-down and bottom-up, right? So this is also related to that one. The good practice is always start from the top, start from what we want to get. So this is actually not only about software engineering, right? So it's also about everything, like every decision we make in our life, right? So we need to know what we aim for, what is the purpose for it. So for example, when I'm preparing this lecture, I need to know like what is the purpose of me presenting this lecture. It's to help you keep in mind the principles of writing good code. Right. Otherwise, if I just covering the content, it doesn't make a lot of sense. It's not that useful. So it is the same when you are writing your softwares. So you need to know the purpose of it, and then you top down and see what you really need to have. So this is also a very, very general principle for all the other approaches, all the other methods, like the top down. So the very top is maintainability, right? So this is the purpose. And then you have all those methods, right? And when you're writing more specific code, you need to also have a like purpose. What do you want to get from that piece of software? Okay, cool. Any questions? All good? So today has less coding. I hope you can a little bit relax and keep up with your labs and the projects. And we are going to have week 6 next week. We'll have no lectures. Yes. And no labs, no tutorials. I hope you can keep up with everything. So, yes, right. Get started with your iteration 2 as soon as possible. I'm repeating this again and again because it's so important. So not wait till after the week 6 and you will have only 1 week to work on your iteration 2. That will be very horrible. Okay, and make good use of the help sessions, forums. Okay, and if you missed any of the lectures before, week 6 is a good opportunity to make sure that you can up to all the lectures. All right, that's all. Thank you so much for coming in person. I really think this in-person lecture is more helpful than the online one, I think. But next week, because it's online, it's easier for me to tap things like coding. I can show more demonstration and we can work on more coding stuff. Week 7. Okay, thank you. Thank you, online people. Thank you. Hey, hello.